Purpose of this video is for you to be able to graph how many radioactive isotopes there are versus time, state half-lives meaning, and chart the number of isotopes through decay. By chart means be able to tell me how many there are of each. So you can draw the graph. Basically, you can tell me what it means in terms of what's going on of half-life and how many you've got of each. Here is a half-life curve. It's a nice curve, right? Steepest at the start, gets less and less steep as time passes, and the y-axis is the number of radioactive isotopes, and time is your x-axis. Now, half-life is the time needed for basically half your sample to decay. Let's pretend we're studying radium, mass number 226 with that half-life. I start with 3,000 atoms of them. After one half-life cycle, half of my original amount will have decayed. 33,000 atoms, and I'll be left with 1,500. After another half-life cycle, half of my remaining atoms would have decayed, and the same thing would repeat itself. After another 1,620 years, half of the 750 would have decayed. Now, if you look between the first and second, the 0 years and 1,600 years, the time was the half-life, and half of my original atoms decayed. It's the same between this first and second point, or the second and third point, and the third and fourth point. The time period that passes is the same, less and less decay, because I'm starting with less atoms to decay. Now, here's another way to explain it, or another visual besides the graph. Say I had 16 atoms. Right, let's say the white is what I'm starting at. At start, I've got 16 white, 0 purple, and no time has passed. After one cycle, 8, or half of the original 16, would decay, turn into something else, and 8 wouldn't. So I'd have 8 of each, and then 5 years would have passed. I made up the half-life. Now, after the next cycle, I've got 8 remaining. 4 of those would decay, and I'd be left with 4. So now I'd have 4, 12, and 10 years would have passed. Then 2 more. Then 1 more. And then that last one would decay. Now, in these problems or in these scenarios, the parent is what is known as the starter or the reactant. The daughter is the product. Let's say I had 45 grams of parent. Start, I'd have no daughter. I'd have 100% parent and 0% daughter. After one cycle, I'd have 22.5 grams of parent, 22.5 grams daughter, and 50-50 ratios. After another cycle, I'd have only 11.25 grams of parent. The rest would be daughter, and it'd be 25 to 75. And after another cycle, I'd have those masses. The mass of the parent keep going down half each time. The mass after 3 cycles, the percentage after 3 cycles would be 12.5% parent, 1/8, and 87.5% daughter.